Okay, 2017, Saturday, 1:30. P.S. If this is boring for you because you don't have questions, open up your phone, open up the practice test, and be taking it, the additional one. Or be grading what you took last night if you have not yet. Or be looking at the questions you missed to find a question you need to ask and be pondering it before we go. Ryle, go ahead.
Oh, are you going to write out?
Yes. Yes. Oh, no. Sorry, we're doing one at a time. So have yours ready. Okay, so we're on number 30. Either it's your additional or it's your mock AP. Ready, set, and I'm going. I love this question.
I don't like it at all.
Too bad. Because, here's why. The 2017, starting last year, they decided that they're going to tweak some of the questions on the exam, and this is a perfect example. They're not testing on anything new. They're testing in a new way. And here's what they're testing. This is a very concept-rich problem. It's very deep in the concept, very deep in the content, but it's very easy in the solving, which is kind of nice, if you can figure out what to do. Kiddos, whenever you have a sentence, there's a subject, right? There's a verb, hopefully almost always. And then there's some sort of, whether it's a direct object, whether it's a predicate nominative, whether it's a predicate, what's the other one, PA, predicate adjective. Anyway, you have some sort of ending of the sentence as well. Now, we see this formula. Technically, I think it'd be a predicate nominative in this one. We see the verb. My question is, who or what is that? Equal length. No, that's in a prepositional phrase. With, of. It's not the subintervals. That's describing something earlier. Keep going back. Oh, it must be the integral. Nope, that's a prepositional phrase. Of, that's describing something earlier. There's the subject of the sentence. Who is? The right Riemann sum approximation is. Well, then what's n? The number of rectangles. Well, then, if that's the approximation, how can I find the actual? What's the limit definition of an integral? Oh, concept rich, very deep in the content. The limit definition of an integral would have us taking the limit as n goes to infinity of a Riemann sum. Have the number of rectangles approach infinity. Well, who's my Riemann sum? That guy. Oh! Really? All we're doing is just taking a limit to infinity of this guy? That's all we're doing. Take the limit as the number of rectangles approach infinity, and that will be the definite integral from 0 to 2 of f of x dx, according to the limit definition of an integral. Pause. The forever card doesn't have the limit as n goes to infinity of the right Riemann sum from I equals 1 to n of f of c sub I times delta x sub I. And doesn't this equal the definite integral from a to b of f of x dx?
Yeah.
Isn't this a Riemann sum? Who's the Riemann sum? So who am I taking the limit as n goes to infinity of? That guy. Dun, 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 dun. Wait! How do I take a limit to infinity? Yes, how do I keep going and solve it? Huh? When you see a limit to infinity, what do you think? Degree tests. Who wins? They're going to be equal. Right? An n squared and an n squared. What's the coefficient on top? 2 times 3 n squared. 6n squared over n squared. 6 over 1. If worst comes to worst, could you FOIL this puppy out? I suppose, if you really, 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 really need to. Just be careful, and you'd end up with 2 times 3n squared plus 2 and 3 is 5n plus 2 all over n squared. Wouldn't you take the highest? Don't go crossing anything off. That's illegal. You can't cross it out, but you can look at these two and say 6 over 1 is 6. Dun, 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 B.
How did you get to the 6 once you realized that the degree test?
Oh, remember you take the leading coefficients?
Yeah.
So 2 times 3 is 6, and 1 is 1. So 6 over 1. And we ignore the lower degrees, because the n behavior, they're inconsequential. Maggie? 28? 17? Okay, the same one, Saturday, number 28. We're on isosceles, right triangle with, ooh, I feel like this is a related rates problem. Nice thing is they gave you the area formula. They told you at the instant, that sounds like a such that, the area is increasing at a rate of, okay, so we know that at some instant, dA dt is equal to 12 centimeters squared per second, and that's when S equals rad 32. All clues. At what rate is the length of the hypotenuse? Who's the hypotenuse? They told us S is what? A squared plus B squared is C squared. So I could say 1S squared plus 1S squared is 2S squared. So I can say that H is equal to 2S squared. But I need this equation, the one that relates the area with the sides. I don't want the side, I want the hypotenuse, so I don't have ds dt, so I have dh dt. Because aren't they asking me to find the length of the hypotenuse increasing? So how do I get rid of and get two options? One option is you can actually get s squared by itself and say, yay, let's get rid of s squared. The other option is you could have been like, I don't know what I'm doing, so I'm just going to do dA dt and hope that I'm right. Bring down the 2 and I get 2s ds dt. I don't want ds dt. Well, you would have come over here and said, oh, dh dt is equal to 4s ds dt. And you could have used that to plug in, or you could have just plugged in to begin with. Either way will work. One way says get h's first, then take the derivative. The other way says take the derivative, then go looking for the h clues. Which way do you want me to go, Maggie? Okay, so then we're getting in terms of h. Oh, I did it in my head too fast. 1s squared plus 1s squared is 2s squared, 2s squared square rooted. Thank you. Gracias. So we go ahead and do h squared divided by 2 is s squared. Good. So we end up with a is equal to 1/2 h squared all over 2, plugging in for s squared. That would end up being 1/4 h squared, so dA dt, which is equal to 12, is 1/4. Oh, sorry, I didn't take the derivative, did I? Reading down the 2, 2 over 4 is 1/2. H dH dt. I'm trying to solve for dH dt, so he's good. Who's H going to be? Didn't they tell us who S was? So we can plug in. 32 is equal to h squared all over 2. 64 is equal to h squared. H is equal to only positive. We're talking about lengths. Just positive 8. 8 over 4 is, 8 over 2 is 4. 12 divided by 4 is, I would say, B. It's on the video. If you need to slow me down, you most definitely can. I'm looking for another question, though. Where are we going? 25, the same exam, 2017? Yeah. Okay, number 25. I love these types. Katrina and I were just talking about these today. I love these types. All you need to know are your basic rules and a little bit more. So, did we?
Yeah.
Oh, it's on the video from yesterday. But pause, just recalibrate. Tell Ryle how you would approach this problem.
First you need to take the derivative that's
First, you need to take the derivative using what rule?
product.
After you take product rule, then you go plugging in 2. Then you go looking at your clues. If you need an f of or a g of, you just take the y's. If you need an f prime or a g prime, you take the slopes. So check out the video from yesterday. All right, another question. Guys, you have A's and B's of 2 full-length AP exams. Just give me questions. Aryan. On this 2017? Okay, number 78, we're in section B. I can go back to A, but Eventually transitioning is good. Okay, number 78. Pause. Everybody check your number 78 if you took the Saturday mock AP. Everybody check. Number 78. Look at your Scantron. Look at your Scantron, number 78. The correct answer, we saw it today. I went and looked at the Scantron, the answer key. It is C. So if you pause, if you put C on number, if you put C, I need you in a color pen to put a big old circle around number 78. And when I check your corrections, if you got 78 right, I know this is integrity, however, keep the answer that you had there. If you put C and it marked it wrong and made it D, put a big old circle and I'll make sure you get the point back. So you can also think, ooh, I had 1 point higher, so maybe that bumps you. Most of you it won't, but maybe just a couple of you it might bump you. As far as from one AP score to another. Ooh. Okay, coming back. So Aryan, it was totally right that it was C, but how many of you guys did not get C? P.S. If you put D, you were technically wrong. Okay, so then coming back. Real quick, just in case someone didn't get C. Asymptotes, if this is an X, has to be a vertical asymptote, right? Asymptotes, if this is a Y, has to be an HA, right? What's the definition of an HA? A horizontal asymptote is a limit when X approaches infinity or negative infinity. So X approaches infinity to equal 2. Well, no, that doesn't seem to work. X approaches infinity to equal 2. That doesn't work. X approaches infinity to equal 2. Oh, that works and that works. Okay, good. We already narrowed down 2 of the answer choices. The other one says vertical asymptote. If there's a vertical asymptote at 0, horizontal asymptote at 2, and my value can only be positive, I could not have come towards the vertical asymptote going down. I had to come towards the vertical asymptote going up. Therefore, as I come to 0 from above, my answer had to be a positive infinity to get my vertical asymptote, and X to infinity had to equal 2 to get my horizontal asymptote. So anyway, you circled it with a colored pen. Hopefully you have it, and I will check it out once I grade for the corrections. Okay, questions? Lowell. On which one? Okay, cool. 2013, number 83. It's the table. You guys have an option. Some of you haven't done this yet. Ugh, killing me. Ideal is to have the section that we're going over done on the additional practice exam the day we go over it. Ideal. Okay, coming back. If you don't have this done, you could be looking at your questions in 2017, and or you could be taking the additional practice exam whenever we have spare space or spare time. But you might want to print out that additional practice exam, be a lot more convenient, or have it on your phone and be accessing it. I'm putting a lot of trust out there. Be productive. Okay, so number 83. If f is increasing over the closed interval 0 to 3, that's the whole thing. Oh. Which of the following could be the value of the integral? Which of the following could be the value of the integral? Well, how do we do integrals if we're trying to approximate? Trying to do a Riemann to add things together. If my f is strictly increasing, question, what's the highest this can be? What's the highest height? 0 to 3. 54 is the highest height. It's been increasing the whole time. Technically, what you could do is you could figure out an over approximate just by doing one big old rectangle of a base of 3 and a height of 54. That would be 150, 162. Is that right? But the bummer is they're all underneath that. And you're like, well, go team. You could have done an under approximate at 0, but that's kind of lame too. So it's somewhere between 0 and 162. Good for an FRQ if you took your Saturday mock AP. Bad for this question if you're trying to solve an answer. So, kiddos, if it's strictly increasing, couldn't a left under approximate and a right over approximate? So we could do a left Riemann sum and then a right Riemann sum and try to find the middle. Or, wait, middle. Couldn't we also do a midpoint? We could do a midpoint approximation because we saw there's some under and some over. To that end, let's check it. So if we were trying to see how close we can get, my way of doing it doesn't have to be your way. Base times height, my first one has a base of 1 and a height of, I'm going to use the midpoint, which is halfway in between. Second one is going to be a base of 1 and a midpoint of 18. Third one is a base of 1 and a midpoint of 40. 4, 18, 40, that'd be 22, 62. That's a midpoint approximation. Strictly that one, the 154 and the 100, I would say are definitely way too big. If we were to do a left and right, we might be able to get a little bit closer because then we'd be doing smaller increments going by halves every time. And so you could have done a left, which would be an under, and a right, which would be over. If you did do a left, we would have a base of 1/2 for everybody. And you would plug in, let's see, the left, the left, the left, the left, the left, and the left. That would have been 14, well, hang it, what was that, 40? 40, 60, 70, 80, 96, 100. 100 divided by 2, is that 50? Is that right? But if I come from the left, isn't that an under approximate? Well, 50 is too small. If I come from the right, I would still have bases of 1/2 because they're all equally spaced. And I would start at 4 instead, or start at 54 and go back. So I'd have 4 plus 10 plus 18 plus 28 plus 40 plus 54. So I would have 50, 90. This is, oh, it's a calculator. You guys could have just added it together. Did anybody do the right Riemann sum approximation? 90, 100, 110, 30, 42, 52, 64, 82. I'm struggling. I might have done that math wrong. I would have guessed B. It's B or C. I might have done my math wrong. I need you guys to help me out. Which one did it end up being? B. Okay. So the midpoint approximation. If that right one ended up being 77, that would be gorgeous because then it'd be an over approximate. I don't think it does though. Because we have 12 and 12 is 4. And 4 cut in half is 2. And I don't think it ends up being perfectly 77, but I would have done the midpoint approximation. Nasty. What else? You bet. Number 6 on 13 or 17? Okay. Number 6 on section A. If a function is given by the average rate, ooh, guys, forever. What's my forever average rate of change? No. That's average value. Are we tracking? Okay, f of b minus f of a. I'm guessing Yvette, it was a plug-in error because 5 minus 1 is equal to 4. Plugging in 5, I end up with 25 and 75 minus 125, which would be negative 50 minus, and then plugging in 1, I would just have 2. So negative 52 over 4 ends up being negative 13.
Yeah.
Riley.
76 on B.
76 on
2013.
13. 2013, number 76. That's the Monday one. Look at that geometry. Right? Geometry, I can do geometric areas. Okay. Guys, it says g of 5. Isn't 5 an x, not a t? How do I know it's an x, not a t? Because it's in the x spot. So where else is an x? So all I'm trying to find is 0 to 5 of f of t dt, and to find 0 of 5, all I need to do is say, hey, start here and find some area, and then add it all together. So this one's going to be 1/2 pi times a radius of 2. And that's going to be added to, because I'm going the right direction. Everything's above, so it's positive. 1/2 times a base of 1 and a height of 3. So I end up with 3/2 plus 2 pi. Dun, 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 dun. Number next one. Maggie. 2017, the Saturday one, number 80.
I don't understand why they use the zeros of the original function instead of the zeros of the critical number.
What was the original function? Well, okay, hold on. Here's a good point. Guys, could we right now find f double prime, because we see concavity and we're like, we need the second derivative. And we could do the 4x cubed minus the 12x minus 8 and then say, yay, let's factor and find the zeros. Wait, we're using calculators on this section, so pause. Maybe you took the derivative wrong. It's still a good calculator problem. Guys, calculator's out. I want you to plug in the first derivative because sometimes they'll force your hand on this. So let me show you how to do it thinking about just the first derivative, the graph of the first derivative, because they do like to ask you questions given graphs of derivatives, right? So if we get the graph of the first derivative, x to the 4th minus 6x squared minus 8x minus 3, anything else will take more time. Getting the zeros of that, I guess you could guess and hope that you're right and there aren't any additional ones. Lo siento, it's coming, I promise. Okay. Given the graph of a derivative, ignore that first function. It's a different question. I think it's one of yours, though. If I graph x to the 4th minus 6x squared minus 8x, I'm graphing the first derivative. Although I fail. X to the 4th minus 6x squared minus 8x minus 3. I'm going to go zoom standard. If your calculator ever starts doing something you don't like, you can hit the on button and make it stop the code. As I'm checking out my graph, I think I see -1 and 3, and that seems kind of indicated over here. Whoa, there's a -1, there's a 3, but there's also a 2 way down here, I think. I could make my window go randomly lower so I can see things a little bit better. Let's visualize this graph, because technically this graph is all you need to answer this question. If I was to solve, -1 is a 0, 3 is a 0, and 2 I think ends up being a relative min. Okay? This is a graph of f prime. How do I visualize the second derivative? It's good even if you got this question right or wrong or didn't take it. How would you visualize the second derivative, though? We still have to think concavity. Justin? Look at the slope. What is f prime doing? Is f prime decreasing or increasing? Because f prime's slopes are f double prime. So this is saying, where is the function f concave up? It will be concave up when f prime is increasing. That's on a forever card. Oh, when f double prime is positive or f prime is increasing. Where is f prime increasing? From 2 to infinity. So f prime is decreasing, aka f double prime is negative. F prime is decreasing, f double prime is negative. Haha, f prime is increasing, f double prime is positive. There's a point of inflection at 2. And where is f concave up? When the slope of f prime or f double prime is positive, which will be from 2 to infinity. Ryle. You took 2017 or 2013? Let me see. Number 80? Ugh. You guys, it's a struggle. There have been multiple ones of you that did not erase fully enough. Please be careful with changing answers. Well, yeah, you can show it to me. A few people have shown me similar things where they erased, but it wasn't enough. It was a very touchy machine. I hope that the AP machine is not as touchy, but please have a pencil that erases nicely and fully for the AP, okay? And a backup pencil that also erases nicely and fully for the AP. Riley, go.
78.
78 on Monday? 2013, number 78. Oh, I like it. Okay. They tell us one integral, another integral dealing with g, dealing with f, dealing with all sorts of stuff. Ooh, that's nasty. There's no 1/2. I'm going to pull that 1/2 out. That's kind of gross. I'm going to go ahead and say the integral of 0 to t of x is equal to 16. Are we good with that? Move that 1/2 over. Who wants that guy? Okay, so now I have this clue here. I have this clue right here. They also tell me this clue between 3 and 10. Well, that's interesting. And then they ask me to solve for this guy. Guys, if you just look at the bounds, I have 0 to 3, I have 3 to 10, and I have 0 to 10. Isn't there something with the properties of integrals that say that I can do something like this? Area from 0 to 10 is area from 0 to 3 and 3 to 10. Well, what can I do? Fill in what I know. Well, what do you know? Well, I know that I don't know this guy, so forget that guy. I have no idea who that is. That's the whole point. I'm trying to find him. This guy, 3 to 10. Oh, they gave me him. So when I have my f of x minus g of x, if I was to actually write it out and take time, which I hope you wouldn't, but just be careful, I'm going to have to do a plus 2, because that's what that guy equals. And what's on this side? 0 to 10. Well, hold on. It has to follow these guys. So I need f of x minus g of x dx. What did they tell me about 0 to 10 of f? 21. Minus, what did they tell me 0 to 10 of g? Well, they didn't. I had to figure it out. Fine. 16. Sweet. 21 minus 16 is 5, and 5 minus 2 is... They give you the pieces. You just have to figure out how to put them together. I'm ready. Next hand I see. Naomi.
79 on the 2017.
Okay, 79 on the Saturday, 2017. A file is downloaded to a computer at a rate modeled by, ooh, rate. F is a rate. Ooh, that's good to know. Where t is time seconds since the start of the download, f of t is measured in megabits per second. Look at them getting all techie all of a sudden. That's new. Which of the following is the best interpretation? Oh, it's concept rich.
That was so close.
It's concept.
So close.
It's all about the concept. Who's f? Rate. Who's f prime? The rate of the rate, right? So can't I say, we did this the other day, can't I say, because this is the rate of the rate, what this really means is f prime is increasing the rate of the, sorry, not f prime, what's the intent? No. Whose derivative is it? Whose rate is it? F. F is increasing at a rate, it's f's rate, of 2.8 mega whatever bits per second when t equals 5. All right, let's match it. The rate at which the file is downloaded. No, that would be f. The rate at which the file is downloaded is increasing at a rate. Oh, that's kind of nice. Time intervals. What the heck? I don't know what's going on there. B. This is an at. It's not an over. It's an at. Ashley. 2013, the Monday one, number 80. Oh, it's so good if you just understand your forevers. Because what do you see? What wording? Now, there are different ways of, but just the forever card, then we'll apply it. Total distance. A to B of?
Velocity.
What do I have? I have 0. I have 2. Who's the velocity? I don't even know how to do a brace anymore, or a bracket, or whatever I'm supposed to be doing. Who's the velocity? That's prime. Dun, 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 dun. Wait, 2. Hold on. 0 to 5. Lo siento. Hold on. Hold on. Yeah. It's E. D would be a no. Because you have to, before you can pull absolute value out, you have to split up at any zeros. So D would have been a no. Needs to be inside. C could have been a maybe, except S is increasing, so velocity is positive. And then velocity is negative. So the negative would have had to flip, which would have been greater than 2. Oh, this should have been switched. It should have been there and there. Those signs were switched. That's why C was wrong. B was doing like integration as net change. That was asking where it's at, not what it's traveled. E. What else do I got? Vowel. On 13. Number 85 on 2013 on the Monday one. So much you could have done in your calculator, and so much you might not have, so you could have gotten it wrong. Who do I have? Position. What are they saying? Find velocity. Derivative. Easy. When the particle is at the origin. Particle will be at the origin when its position is 0. The x, when the x is 0. So I need to find, by hand? No, you have your calculator. Graph, cosine of square root of t. They say t greater than 0, so if you want, you can make your window not be so negative, but whatever, either way. Too bad we couldn't do that with people, including myself. Anyway, so, lo siento. Plugging in cosine, oh, that's not going to work. Cosine of square root of t. Ignore my first one. Make sure you're in radians, and no pre-cal kid has borrowed your calculator. But I'll remind you for the AP. I'm trying to find the zeros, right? Now careful, it says the first instance. So I'm looking when it first hits 0. Okay, graph, graph, graph. Dirt, 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 dirt. 0. Zeros. And you do second trace. 0. Shortcut. Yes, you could scroll, scroll, scroll. Or you could be like, wait, this is like 0 to 10, so why not just hit in like 1's definitely before and like 5's definitely after? Sweet. Shortcut. You can also scroll. Now, pause. I have 2.467, right? It says, what is the velocity at the first instance? The particles at the origin. Pause. Eyes up, eyes up, eyes up. The job of this question, whether you have no clue what's going on, is to find the derivative of this guy at that point. Can't I quit? Can't I stow? Can't I then go ahead and take a derivative using my calculator and not making any mistakes in the process? I'm using y2 because y1 I was storing to be something else. Oops, that's not going to work. That's going to be my A. I'm doing it at A, and I can go ahead and go back and use my y2. What did I just do? What did I just do? What did I just do? I avoided mistakes, if I can actually get it typed in. Lo siento. There's a lag. It messes me up sometimes. Okay, now y2. Go! Dun 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 dun. I get 3.18. See. You can and should, if you ever have to find a derivative at a point on a calculator problem, multiple choice or FRQ, use your calculator to do it. Ashley. 2013, the same exam, number 88. Love it. We're looking at -1, 1, and 0. That's nasty. Oh, that's really nasty. Okay. They're not just, usually it's stuck at 1x, so you can just kind of look. Well, I at least know what x's are looking at. 0, -1, and 1, right? What do I know? This guy, I know that f of -1 is positive. I know that f prime of -1 is 0. I know f double prime of -1 is positive. Concave up, flat, and then above the axis. So I have above, horizontal tangent line, concave up. At 0, I know that f of 0 is positive. It's above. F prime of 0 is positive because it's sloped up. And f double prime of 0, it could be a possible inflection point. It could be like a 0. Or it could be part of the concave down portion. It could be negative. We'll come back to that if we need it. This one, I know that f of 1 is positive because it's above. F prime of 1 is negative because it's sloped down. F double prime of 1 is maybe an inflection point, maybe positive because of concave up. We'll come back to it if we need to. Okay, so what do we got? F prime of -1. That's a 0. F prime of 1, what are we doing? Increasing order or decreasing? Oh, sorry, less than. F prime of 1 is a negative. No, 0 won't go before negative. That's lame. Okay, F prime of -1 is a 0. F prime of 0 is a positive. F prime of 1 is a negative. Forget that. F prime of 0 is a positive. F prime of -1 is a negative. Forget that. F prime of 1 is a negative. F prime of -1 is a 0. F prime of 0 is a positive. Dun, 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 dun. -0, positive goes in order. Done. Concavity, slopes, above, belows. Another one. Yeah, Jesse. 2017, number 12. Number of gallons modeled by. So this is how many gallons. They want rates, gallons per minute, 3. Not average. Instantaneous. At 3. How do I find an instantaneous rate? I take a derivative. -2 times t when t is 3. The rate derivative. Number next one. Who's saying that? 13 on this one?
Yeah.
2017, number 13. Guys, you tell me. It's a slope field. We're matching with dy dx's. Am I looking at the slopes or the flow? The slopes. Okay. I see 0 slopes at equals 4 dy dx. Needs to be 0. And when seemingly when y equals 0, maybe dy dx is also 0. I have positives here, negatives all around there, and I have positives all around there. All positive, all negative. Okay, so if y is 5, everything needs to be negative. If y is, that's lame. Okay, if y is in between, y is 4, everything is 0. Well, that's lame. They're all the same. If y is 0, everything should be 0 also. Now, if y is 0, that has no impact there. If y is 0, okay, now we're down to B, C, or D. Looking at the signs, hold on. If y is a negative, if y is -1, -2, -3, I need positive slopes. So if y is a negative, like a -1, -1, that's going to be a negative. That doesn't work. Okay. If y is -1, negative, positive, that's going to be a negative. That doesn't work. If y is a -1, positive. So what I finally got down to is I need the slopes to be positive even when y is negative. So I was plugging in when y is -1, I need a positive slope. Whether x is this or this or this, All those slopes were positive. That was the only one. If y is a negative, like -1, a positive times a positive is a positive. Number next one. I can do 2 more, I think. Yeah, Maggie. 2017, number 88, the Saturday one. Oh, good, good, good. Period 1 asked this one too. I have F, I have G, I have a line tangent, I have parallel, and I have a line tangent. Some of you might be like, oh, I need a whole tangent line. What's my clue? Same slope. So I need F prime of, careful, F at 2 to equal G prime at A. Yeah. So it technically is a calculator problem, so you could plug this guy into your calculator, take the derivative. As you guys can tell, it takes me longer. So I'm just going to be super, super confident and pretty dumb because I'm doing it by hand. But plugging in 1 over u times u prime, so 1 over x squared plus 1 times 2x. I need to plug in my 2. I'm setting that equal to g prime, which will be 5x to the 4th plus 3x squared. Yes, you can make your x's into little a's, whatever. How do I do it? It's a calculator. What are you going to do? 2 choices. Do you want to do intersect or do you want to do 0? Intersect, I do y1, y2. 0, I subtract and find the 0. I'm going to keep doing it. If you want it, you can go ahead and stay. If you don't want it, you can go ahead and go. It will be on the video. But I'm going to go ahead. Maggie, what are we doing? Intersect or zeros? Okay. I'm going to be super lame and dumb and just go ahead and... Yeah. I mean, you could technically be super snazzy and you could actually do the derivative in here. You could do the derivative of ln of x squared plus 1.
No.
And then the other one would be 5x to the 4th. Well, I took the derivative because you can't do a derivative if it's not at a point. Does that make sense? Yeah. So then when I go ahead and graph, I'm going to do zoom standard again just because I don't know. Hopefully we only see... There's one. There we go. So I'm going to zoom in real fast. It would go way faster if I just did the number. 4 over 3. Anyway. Ooh. Hold on. Oh, A is a positive constant. There we go. So in second calc, we can do our intersect feature, and we would just do it on the positive side. Does that work? 0.447? Yeah.